So my name's Brian Dooley and I'm the product owner for Demand Forecasting Navigator, which is our new demand forecasting application that's part of the AIMMS Supply Chain Navigator suite of pre-built supply chain solutions. So the purpose of this video is to give you a quick introduction to the application, its key features, and really what it's aiming to do, and how, as a demand forecaster, you would work within the application. So before we dive straight into the application, I thought it would be useful just to cover off some of the key features that we've incorporated into the application, and a lot of these have come about as the result. So we've carried out some quite extensive research into the current state of demand forecasting, with well over 300 supply chain professionals, and kind of as part of the result of that research, we've baked that into the design of the application. So one of the first things we've tried to do is the whole idea is we want to automate labor intensive work. So bringing in of history, identifying outliers in that history, treating those outliers and cleaning the history, then being able to define multiple levels to your forecasting hierarchy, so that you can forecast at different levels of aggregation. Should be able to get a better statistical forecast at greater levels of aggregation, and then force that down, disaggregate it down to lower levels. And we wanted the application to be able to analyze that history. So again, doing the heavy lifting from the analytics point of view, identify trends, detect any seasonality, and based on that, select the best statistical model to use for that particular demand history, and then I guess finishing it all off, once we've selected that statistical model, then as we go through each forecasting cycle, so we roll into another forecast period, we wanted to incorporate a learning algorithm that could continually, based on the actuals that have come in, fine tune and refine both the choice of statistical model being used, but also the parameters associated with that model. So again, the whole idea is to really remove some of the burden from the demand forecaster, so that they can rely on the technology to do the initial analysis, treat the history, come up with the best statistical model, and just allow them the time then to review the resultant output. And that's kind of summarized in this flow diagram at the bottom of the page, which is essentially the steps that the application supports. So every forecast cycle, we're rolling forward a period, we're bringing in new demand history to add on to the history we've already got in, we're analyzing that history, identifying any outliers, and treating those. Then based on that cleaned history, generating the best statistical forecast that we can, and then providing an option then for the demand forecaster to critically review those proposed forecasts, make any final changes to the models, and then resulting in a statistical base forecast that can be exported and used in other planning solutions, or if you're using our S&OP application, then that's a seamless integration straight into S&OP for the start of the demand review process then. So that's the the key features of the application and kind of some insight into what we've tried to achieve. So if we go straight into the application now to take a look at that. So what we're seeing here is the first stage of the forecasting process, and the idea here is to analyze our historical data, so historical demand, sales, shipments, whatever that might be, and identify any outliers in that data, and adjust those accordingly so that we get a cleaned demand history to give us the best opportunity to fit the best statistical model to it in the next stage. So if we just concentrate on the chart first, which explains everything that's going on really. So the red line on the chart is my original historic data, and you can see here my history period runs from 2014 through to 2018. The dark blue line is the mean of that historical data, and that's calculated on a centralized 6-month rolling basis. So it's using 3 months from the past, 3 months from the future, and then what's used to detect the outliers then are these upper and lower control limits in the pale blue, and these are set. So this is a configuration parameter that the user can set based on a number of standard deviations away from the mean. So for example, if we wanted to cover 90% of the demand, then that would be 1.2, 1.28, I think it is. Standard deviations would be where those control limits are set. And then you can see what happens. So if we look at this example here, that's clearly an outlier. It's way above the upper boundary, and again, user configuration setting is to tell the system, if you detect an outlier, what do you then want to do with it? And there are two choices. So in this example, we've selected the option to simply drag that down to the upper boundary, or similarly over here, where we've got an outlier that's below the lower boundary, we've just dragged that up to the lower boundary. Our other option is to set the outlier equal to the mean value in that period. So you get the idea of what it's doing, how it's identifying the outliers, and essentially what it does is proposes that cleaned data, which we can see in this table below that we're looking at here. So this is showing all of that data that's above. So we can see our original historic sales data here, the proposed cleaned data, and a comment. So the system automatically, so we can see there March 2015. There's an upper outlier, which is probably that one. Yeah, March 2015. So you can see it's highlighted it in red, shows me the value it intends to correct it to, pre-populates it with a meaningful comment, so that when we come to look at this data in 6 months, 9 months, 12 months time, we've got some meaningful comment in there that gives us an audit trail as to why it was changed. And if we wanted to, at this stage, we could go, yeah, I'm fine with all of that. Select this check mark, and that will mark that record then as, yeah, I'm happy with that. Please use the use cleaned data. But one of the options we also have is we can manually change the data. So let's take our lower outlier example here, 664,000. So based on our automatic correction, it's going to increase that to the lower boundary. But let's say we know that actually in that particular October 2017 period, we had supplier issues, and actually had we not had those supplier issues, our sales would have been much closer to the mean, let's say 1.5 million. So what I can do here is override that proposed change, change it to something that that I know is not 15 million. Let's 1.5 million, and then I can give it change the comment if I like to, and then we can see there then that's now changed that cleaned history up to the 1.5 million. I can then click the tick mark to say, yeah, I'm happy with that. I've reviewed the history, made any changes I want to. That's now locked down, and we can go on and review the data for the rest of the records, and if we've reviewed it all and we're happy, we can then click the main calculate button, which will then take that cleaned history, and what's happening now is it's first using a heuristic to analyze the demand history, look for what's the level, what's the trend, is the demand intermittent, is there any seasonality to the demand, and based on that, giving us the best statistical model to start off with, and then, as I said in the PowerPoint, once we've done that initial selection of the model, then each subsequent forecast cycle we go through, the learning algorithm then takes over, analyzes the new actual history against the forecast, and refines and updates that statistical model accordingly. And you can see that calculated pretty quick. This is only a small test data set. If you were using, say, a very large data set that may take some time to calculate, you can close the browser down, switch your PC off, come back to it at another time, and load in the results of the calculation. So if we go to take a look at the forecast now, so we'll go to the forecast review screen, and so lots of things going on here. If we focus on the chart first, and then we'll look at the tables in some detail, and how the forecast pyramid works, the forecast hierarchy works, and the interactions there. And we're just concentrating on the chart. So what we have here is the brown line is our cleaned historical data that we analysed and corrected in the previous step, and then the green line is the forecast. And so if you recall, our historic data went up to December 2018, and then from that point forward, that's our forecast for the future periods, and we can also see what the current statistical model would look like if we backfitted that over the historical data. So very visual. We can get a quick a very quick feeling for how good a fit this forecast is against the history. And then in this this little side panel here, we get kind of the key information related to this particular forecast. So we can see which method has been used. So in this example, it's hot winters. So clearly the heuristic has detected some seasonality. We can see that The periodicity it's detected in that seasonality is 12. Then the various smoothing parameters it's chosen to use for the Holt-Winters method, the alpha, beta, and gamma. And then we get a tracking signal calculation. This is standard calculation, cumulative error over the mean absolute deviation, and gives us a really good indicator as to how good a fit this statistical model is to the history. So 0 would be perfect. The smaller the tracking signal value is, the better. If it's negative, then that suggests over forecasting, and if it's positive, then that suggests under forecasting. And kind of the recognized boundaries there are kind of +4 to -4 is considered good from a tracking signal perspective. So what we have here at the side then, so again, you know, trying to use the application and the technology to really focus the demand forecasters' efforts on what they need to look at. We can apply some filters. So we can set a filter here using tracking signal. So we could set that to -4 and 4, and only review those items that are outside of that and potentially going out of track, need a different model selecting. But also we can zoom in and look at items that have got a small number of periods of history. So there, you know, the heuristic and the learning algorithm may struggle to find the best statistical model, and we may need the input of the demand forecaster. And similarly, we can filter based on number of 0 demand points. So if we've got a lot of periods with 0 demand, again, that's an exception we may want to look at as a demand forecaster. And I just get some useful information at the top here. So my total history length is 54 periods, which we saw in the data cleaning step where we saw it all. And right now, as the user, I've chosen to set this configuration up to use the last 36 periods of history to demonstrate my to calculate my statistical forecast on. So again, just some useful filters to help us zoom in. So that's the chart and the key information. If we go to the 3 tables below, and I just want to dwell on these for a couple of minutes, because this explains the forecast pyramid and how the hierarchy works. So you can see here, these are titled forecast results for level 1, level 2, level 3. So we have 3 levels to the forecast pyramid, and they use our standard hierarchy model in all of the SC Navigator applications. So that's based around customer, product, and location. So as a user, I can define exactly the hierarchy and groupings I want for customer, product, and location, and then define for level 1, 2, and 3 what level I want to see at each of those levels of the hierarchy, with level 1 being the bottom of the pyramid, so the most granular level. Level 2 then is a aggregation on top of that, and then level 3 is the top of the pyramid and a further aggregation on top of that again. So in this example here, you can see at level 1, I'm using a customer grouping called size, which gives me customer big and customer small in there. If I scroll down far enough, customer small. For product, I'm using SKU, so I've got the individual items, and for location, I'm using a grouping called region, for which I've got North America and EMEA. And then as I step up through the levels of aggregation, then at level 2, I'm staying at my size grouping for customer. I've now gone up to product family for the product grouping, and for location, I've now gone up to zone. And what you see here at the side of level 2 is this additional text that says master level. So what we have the ability to do is to allocate one of those 3 levels, and it can be level 1, 2, or 3, whichever is most appropriate for our particular setup. We flag one of those as the master level, and that serves 2 purposes. So in the data cleaning step we looked at previously, that's all done at the master level, and when we get to the end of this forecast review step, the exported forecast to be used in our S&OP application or any other planning application is done at that master level. So let's just scroll along a bit here to so we've got some forecast periods. So some other elements to the data. So here at level 2, so middle of the pyramid, we can see we've got the cleaned historical sales in there. So that's the demand history that's been used for the forecast. We've then got a bottom up and a top down forecast. So what this is, the bottom up forecast is the aggregated result, so of all of the combinations of customer, product and location that belong to this customer big product group 1 global grouping. That's the result of all of their forecasts at that level aggregated up. Top down is the opposite, so this is the disaggregation from my top level forecast at level 3, and then I've got base forecast in here, and base forecast is the statistical forecast that's been calculated by the application. And then the final value, which you can see is editable, it's in blue, is the proposed forecast. So right now we've made no changes or modifications. So in every table, base forecast equals the proposed forecast. As I start to make some changes, the proposed forecast changes, everything else remains constant. So I've always got that there as a reference point. So let's go to let's do some review. So let's look at our level 3 forecast. So the top of the pyramid. So this is a typical way I may work as a demand forecaster, and here I'm looking at all my customers grouped together, all my locations grouped together, and my group one products. And if I look at that, the forecast associated with that, I can see that at the top here. It's chosen halt, so double exponential smoothing, because it's detected some trend in there as well as a level. But actually, I think there's not a strong seasonality going on here, but I think there's some seasonality going on. So I want to change the model at level 3 and use that to force down to the lower levels. So I'm going to choose halt winters because I want to apply some seasonality. I believe the periodicity to that is 12. I'm just going to set some fairly standard smoothing parameters to start off with, and then once I've done that, I can then hit this button down here to recalculate the forecast for that particular record. So you can see that's now recalculated. I'm quite happy with that actually. It's picked up the periodicity, a bit of shape, still got the trend in there. So yeah, I'm quite happy with that as a forecast at the top level. So if we just go back to our level 3 table, you can see here, if I just scroll along to where the forecast starts, that's now changed to orange to highlight to me, yeah, you've now made a change to this proposed forecast. And if I look at level 2, which is my master level, and I can expand any of these tables if I want to, so it's easier to work with the data. I can see the two records that have been altered accordingly. So it's my big customers product group 1 for all locations, and small customers product group 1 are the two level 2 records that have now had their proposed forecast updated by that changed forecast at level 3, disaggregated down. So if I have a look at those, my big customer grouping, I kind of expect to follow the seasonality. So yeah, that looks good. Quite happy with it. Actually, what I might do here from a workflow point of view is say I'm going to mark that as reviewed. I've taken a look at that. I'm quite happy with it, because if you can imagine, as a demand forecaster, I'm probably doing, this is not something I do in one sitting. I might do this over a period of days. So it's useful to be able to flag that forecast as reviewed, and I can come back in here and use this filter to only let me look at reviewed items. But the smaller forecast or the customer for the forecast for small customers, yes, it's picked up some seasonality, and it does look like the seasonality there, but actually in the discussions we've been having, we think actually the smaller customers behave a lot more closely just to the last few months. So actually here, I want to change the model used for the small customers to a moving average, and I just want to do that on the last 6 months. So I can now, although I've recalculated it at level 3 and forced down, I can recalculate that forecast independently on one of those lower levels. So here, my customer small grouping, to use a different statistical method. And what will have happened here, so my one I've already reviewed still remains exactly the same. So if I look at that, that's still got that seasonal profile that's been brought down from on top. I've changed this record here, which will have reaggregated back up to the top now and changed that forecast at the top level at level 3. And again here I can say, yeah, I've had a look at that. I'm quite happy with it. Let me mark this record as reviewed, and it adds the highlight to that. So you can see how I can work independently at different levels. I can make a change at a lower level and it'll aggregate up to the top ones. I can make a change at a top level and it will disaggregate down, and then I can make some minor changes. If I want to see all of the methods that have been chosen for everything quickly, I can take a review in these tables. So then if I just expand, this is my level 1. So for all of the items, I can see the statistical method that's been chosen, any parameters that have been set for that particular method, what the tracking signal is, and then also quite usefully, the system calculates me some segmentation data as well. So an ABC Pareto and an XYZ for variability. So I get a 3x3 matrix calculation there for rate of sale and variability, which I can use in other applications, or when I'm reporting forecast accuracy, that type of thing. And in here, if I want to, again, I can change a forecast method in here and change the parameters and launch a recalculation. If I want to change lots, I can enable these checkboxes and select multiple items, and then use this here to change them all to the same forecast method if I want to. So it gives me some options around mass changing the forecast method if I so desire. So final stage then is, so we've reviewed all of our forecasts over a period of days, whatever it might be. And I guess one of the final things just to point out at my master level that we can also do is let's say, for example, here, I've been playing around with it, and actually I'd really just like to go back to the base forecast. I can simply click set to base, and that will reset it back to the base forecast. Equally, I can if I'm happy with the forecast at a higher level, so although we recalculated our level 3 forecast with some seasonality, if I'm happy with it and I just want to use that at this level, I could set the forecast here to the top down that had come down from the top, or equally to the bottom up. So I've got various options to make some changes to the forecast, and that really is it in terms of the two key steps to the process. So we've got our demand cleaning step, where we're analysing the history, automatically identifying outliers, suggesting how we should adjust those, giving the demand forecaster the opportunity to just accept that adjustment or overwrite it with a choice of their own, and then taking that demand history, calculating statistical forecasts at each of our 3 levels in our forecast pyramid, using the learning algorithm to continually refine and adjust and update those, and then give us some nice functionality to review, change those forecasts at any level and see the corresponding impact on the other levels. And so the final step then is, if we finished, is to approve all the forecast changes. So I can hit that button there. Everything turns green to say it's been approved, and I can then go to export the results, and I get a dialog box then to give it some sort of name and description, and then I can export that then, which creates me an export file I can use to use in any other applications I want to, and also makes the data available to our S&OP application then to bring it straight into step 1, the demand review step in S&OP. So that's it. That's everything I wanted to show. It's a fairly quick tour. Hopefully it's given you a reasonable idea for the capability and functionality in the application, and by all means, please reach out to directly to us through the website or to your main contact at AIMMS to get more information and detail on it. So with that, thank you very much, and have a good rest of your day.